Alright, so here we are with the 4-3 assignment. Oh, these aren't the answers. They will be soon. Alright, so in exercise 1 and 2, we need to identify the one angle that is not coterminal with all others. So basically we're just going to try to make these into their most unit circle between 0 and 360. So as I look at it, this is the only one that's between 0 and 360, and so now I'm going to put the rest of them in between 0 and 360. So if I subtract 360 from 510, I end up with 150, and that matches. If I add, because this is negative 360 to 210, I get 150, and so that one's also 150 degrees. If I take away 360 from 450, I get 90, and so this one here is definitely not going to be 150. And then just to double check, if we subtract 360 and then another 360 from 870, we get 150. And so the piece that is not coterminal is going to be the 450 degrees. Same thing is happening in number 2 here. It's probably easiest for us if we just convert each of these into degrees first, because I am not going to be, well, okay, we'll just do it with units, with radians. So basically this is over 3, and so if we're going to subtract 360 in the way that we did on the previous one, we have to remember that in radians 360 is 2 pi. And the fact that 2 pi needs to have a divisor of 3, so if we multiply it by 3 to the top and bottom, we actually have 6 pi over 3. So that is the piece that we're going to add and subtract to each of these in order to get something within the unit circle. And 5 pi over 3 is in the unit circle. It's in quadrant 4, and so that's kind of where we will start our base. And all the rest of them we're going to see if they can equal 5 pi over, 3. So, for instance, this one here, I'm going to add 6 pi over 3 to 5 pi over 3, and I'm going to get, let's see, add, if we have negative 5 and we're adding 6, we have pi over 3, and pi over 3 is not the same as 5 pi over 3. Then we have 11 pi over 3, and I'm going to, so this is probably the one, but I'm going to subtract 6 pi over 3 from this one in order to try to get to 5 pi over 3, and 11 minus 6 is 5 pi over 3, so that should be fine. To negative 7 pi over 3, I'm going to add 6 pi over 3, which will not be enough to get it positive, and then add another 6 pi over 3. So basically we're adding 12 pi over 3. So if we add 12 to 7, we are going to get 5 pi over 3, so that one works. And then the last one, 365 pi over 3, honestly, we don't really need to do it because we already know that this one is not equal. However, we can subtract as many 6 pi's as we can from 365. Turns out we'd be doing it 60 times. 60 times 6 makes 360, and so if we subtract 360 pi over 3, we're going to get 5 pi over 3, which is of course what we wanted to match. So in that case, the one that does not equal is negative 5 pi over 3. Alright, moving on to our next one, we're going to evaluate the 6 trig functions of this angle that would be right here, the one by the origin. And so in order to do that, we have a triangle here that's dropped down to be 90 degrees. And that triangle, if we draw it a little bit bigger to help ourselves out, went over 4 to get there, so 4 for this side length, and down 3 to get here. We know that by a 3, 4, 5 Pythagorean triple triangle that this would be 5. And so from there we should be able to do all of our 6 trig identities. So we have sine, cosine, and tangent, and then their flips or reciprocals of cosecant, that's a C, secant, and cotangent. So if this is the angle we're standing on, then this is the opposite side. We have a hypotenuse here and an adjacent side. And so sine, making sure that we have that negative in, is negative 3 over hypotenuse, so 5. And then cosecant is going to be the flip, negative 5 over 3. Cosine is going to be adjacent over hypotenuse, so 4/5, and then the flip for secant, so 5/4. Tangent is going to be opposite over adjacent, so negative 3 over 4, and then negative 4 over 3. And then this, so that's all of our 6 ones there. And then this next one here, same idea. We go over 3 and down 5 to get to the point. And so our triangle has 3 here, negative 5 here, and then via the Pythagorean Theorem we can find out what the hypotenuse has to be. So 3 squared plus negative 5 squared means that we have 25 plus 9, which is going to be 34. And so that means that our C is the square root of 34. So not perfect, but there it is. And then we're going to do all of the 6 trig identities. So, identifying the opposite, adjacent, and hypotenuse, our sine is opposite over, because we're doing SOHCAHTOA. Our sine is opposite over hypotenuse, so negative 5 over the square root of 34. And then, of course, its flip is negative square root of 34 over 5. Cosine is going to be adjacent over hypotenuse, and then the flip of that. Tangent is opposite over adjacent, so negative 5 over 3, and cotangent is negative 3 over 5. Alright, moving on, we're looking for point P given that's on the terminal side of the angle, so basically looking at the previous ones, they're saying this point here. And we're going to evaluate the 6 trig functions. If the function is undefined, we need to write undefined. Sounds good. So, taking a look at this first one here, we have negative 4 and negative 6. So we're going to be over in this quadrant over here. If we imagine this shape here, we are going to have negative 4, so it's going back 4, and then negative 6, so down 6. And so we need to find our hypotenuse in order to evaluate the 6 trig functions. I did not provide enough room on this. So, in order to do that, we're going to take negative 4, which is one of the legs, square it, add it to negative 6, which is one of the legs squared, and then that's going to be our hypotenuse squared, so 16 plus 36. So it looks like we have the square root of 50 as our C value. And so if we fill in all of our trig identities, we've got sine, which is opposite over hypotenuse, and if this is our angle, opposite is over here, hypotenuse is here, and adjacent is here. So sine, cosine, tangent, cosecant, secant, and cotangent. So sine is going to be opposite negative 6 over hypotenuse, which is square root of 50. Cosine is going to be negative 4 over square root of 50, and tangent is going to be opposite over adjacent, so positive 6 over 4, or 3/2. Usually it's not very helpful to simplify this, so I'm just going to keep it as negative 4 over negative 6, actually. Alright, and then the square root of 50 over negative 6. The flip is this one, negative 50 over 4 being negative on top or bottom, doesn't matter, and then the last one, the flip of negative 4 over negative 6. So we'll try number 10 over here. And so visually we're going to negative 3, 0, which is right here. Of course, that is a very non-triangle there. It's our straight line. But if we think about it, that means that its side length is -3. Just for general ideas, its opposite is going to be 0, and its hypotenuse is going to be 0 as well. So again, a non-existent existent triangle. So if we go ahead and identify each of these, again, sine, cosine, tangent, cosecant, secant, and cotangent. This is where that piece in the direction of if it's undefined, you would mention that. So we're going to say this here. If the function is undefined, write undefined. So sine is going to be opposite over hypotenuse, and so that's going to be undefined because it's 0 over 0. Cosine is going to be adjacent over hypotenuse, and so that's going to be undefined. Tangent is going to be opposite over adjacent, and so that's actually just 0, because 0 over -3 would be 0. Cotangent, of course, if you flip it, would be undefined. Versus cosecant, which is the flip of sine, which should have been 0 over 0. Yep, that's still going to be undefined. And then secant, which was the opposite of cosine, which should have been -3 over 0, will be 0 over -3, so 0. So basically everything's undefined except secant and tangent because they actually divide by a number. Alright, then we move on to this one here, number 11, which I didn't have room for on the other page. And so if we go over 22 and down 22 to get to our point P, we make this triangle here. We are going to want to find our missing side length, our hypotenuse, by looking at 22 squared. 22 squared is 484. And so we've got 2 of those, which means we have 968, which we will be square rooting. And of course I'm not going to keep the decimal because it doesn't simplify nicely, so we'll just have 968. Square root of 968. Alright, this is our opposite side, this is our hypotenuse, and this is our adjacent. And we are going to do all of our trig. So sine, cosine, tangent, cosecant, secant, and cotangent. Alright, so doing our fractions here, sine is going to be -22 over the square root of 968. Cosine is going to be 22 over square root of 968. Tangent is going to be opposite over adjacent, so -22 over 22. Again, that could be -1, but especially if we're trying to revert back, it's always nice to actually know what the side lengths were. Cosecant is going to be the flip, so 968 on top and -22 on bottom. Secant is also the flip, but with a positive 22 on bottom. And then cotangent, if you flip -1, is just -1 again, but it is technically 22 over -22. So, alright. So then we move on to numbers 13 through 16. They want you to state if the sign is positive or negative for the value of taking sine of something, cosine of something, and tangent of something. And so that goes on our notes from the previous time when we talked about, let's see, sines, cosines, tangents. Of course, you can reference your notes if you would like. Where sine and cosine are positive in quadrant 1, and tangent is positive. Cosine is negative here and positive, and so tangent is negative. Sine and cosine are both negative, but that means tangent is positive. And sine is negative and cosine is positive. So, anyway, just a reference so that we can kind of see. The first one that they're giving you is a range of values, and so remember that we talked about this being a coordinate, but it's actually saying when we're looking at values between 0, I guess they're thetas, when we're looking at thetas between 0 and pi over 2, so in quadrant 1, they want to know what are sine, cosine, and tangent, and so kind of already did that over here. So that's going to be number 13. Number 14 wants from pi to pi over 2, and so that's quadrant 2, and so again we did that here, and so that's number 14. 15, they want that third quadrant, and then 16, yeah, is the fourth quadrant. So we can just kind of do it this way, where S, C, and T would be sine, cosine, and tangent. So this is number 15, and this is number 16. That's nice. All right. The next one, they want you to determine it without using a calculator, so same idea now that we've set this up. Cosine of 143. Well, 143 is in quadrant 2, and so that means that if the cosine is there, we're looking at a negative. A tangent of 192 is just after the 180, so it's going to be in quadrant 3, and in quadrant 3, tangent is positive. Alright, moving on, we're going to evaluate without using calculator by using ratios in a reference triangle. Super. So they want tangent of 300 degrees. So looking over here, tangent of 300 degrees would be the fraction of the x sine, the y over the x. So negative square root of 3 over 2 over a half. Which of course multiplies by the reciprocal, so our 2's will cancel, and so technically it's just negative square root of 3. The next one is doing cosecant, and remember that cosecant is 1 over sine, and so we want 1 over sine of 3 pi over 4, so looking for 3 pi over 4, that's over here, and we want sine, so that's the y value, so square root of 2 over 2, but it's 1 over that result, so that means we'd flip it. Square roots of 2 in the denominator is never okay, and so they'll probably give you, once you multiply the top and bottom by square root of 2, they'll say that the answer is actually 2 square roots of 2 over 2, which is really just square root of 2. So anyway, the book will kind of mention that, because having a ratio, radical in the denominator is like a no-no. Okay. So 7 pi over 3 for cosine, that's x value. 7 pi over 3 does not exist on here, so it's probably like a rotation of one of them. So we're going to end up subtracting 6 pi over 3, because that's 2 pi, 1 revolution, in order to realize that we're actually trying to do cosine of pi over 3. So if we do the x value of pi over 3, we end up being up here, and so our x value is a half. The next one is 13 pi over 4, and I don't believe that that is on the unit circle either. It's something new. So we just need to subtract a form of 2 pi, but over 4, so it's going to be 8 pi over 4. Which means we have 5 pi over 4. And so we're looking for cotangent of 5 pi over 4. That's here. Cotangent means that we're going to flip it around, but either way they're the same, cotangent and tangent, because they're the same number being divided. So technically cotangent is going to be the negative square root of 2 over 2 divided by the negative square root of 2 over 2, which is just going to be 1. Then we have cosine of 17 pi over 4, and I know that that is not on the unit circle, so I'm going to subtract the 8 pi over 4, and actually again, because that's only going to be 9. So if we subtract 8 and subtract 8 again from 17, we end up with just pi over 4, and they want the cosine of that. So pi over 4, cosine is our x value. So cosine of pi over 4, our x value is going to be a half. Oh, sorry, square root of 2 over 2. I was just kind of forgetting from one slide to the next. All right. And then 19 pi over 6 for cotangent. First thing I'm going to want to do is make 19 pi over 6 into a unit circle value. And so I'm going to subtract, let's see, 2 pi, but over 6 is going to be 12 pi over 6. So if I subtract 12 pi, I get 7 pi over 6, and that's not really a value on here. Is it 7 pi over, oh it is, here it is, ha. And we want cotangent, so that means we want to do the x value over the y value. So negative square root of 3 over 2 over negative a half. And then, of course, those negatives will cancel, the 2's will cancel, and so we end up with the square root of 3 as the cotangent of 19 pi over 6. And, of course, you can do this with a calculator to check. So if you do this in your calculator, 1 over tangent of 19 pi over 6, you're going to get the decimal equivalent of square root of 3. And moving on, in 38 and 40, we're going to identify the sine, cosine, and tangent for the given quadrantal angle. And so remember that that is the one that is on an axis versus one of the angle identities. So negative 270, very weird moment because it's negative, means that we're not down here because that's positive 270. If we start here and go counterclockwise 3/4 of the way, which is 270, we're actually at positive 90 degrees. So what they're asking for is sine of 90 degrees, meaning the x value, and sine of 90 degrees is, sorry, our y value, that's 1. Cosine of 90 degrees is going to be 0, and tangent is going to be the sine over the cosine, and so that's going to be undefined. The next one, 11 pi over 2. Let's see, 11 pi over 2 is going to be on an axis, so we're going to have to subtract some over 2's. So negative 4 pi over 2, and then another 4 pi over 2, and then we'll finally get 3 pi over 2. And so 3 pi over 2 is actually 270 degrees, not negative 270. And so we just need to think of this point down here, and what its sine and cosine are. And this is cosine and this is sine, so we can kind of put those in already. So sine of theta is of 270 is negative 1, cosine of 270 is 0, and then tangent is sine over cosine, and so again, since cosine is 0, this is going to be undefined. And so 2 more sections here. The first one, evaluate without using a calculator. Sounds like a plan. We're going to find the sine and tangent if the cosine is 2/3. So other than the cosine of 2/3, meaning the adjacent side is 2 and the hypotenuse is 3, they're also telling you that cotangent is going to be positive. So looking back at our previous example here, if cotangent is positive, then, is it positive? Yeah. Then tangent is positive, and so we're looking at either being in quadrant 1 or quadrant 3. And so if I'm looking for cosine, that means that I'm looking for quadrant 1, that's up here, or down here. And so it can't be, let's see, this is, where's the adjacent side here? The adjacent side can't be 2 and both of them being positive here if we use this triangle, because that means that the adjacent side is going to be negative because we'd be going down. So in that case, it's going to have to be in quadrant 1. And so that just lets us know that sine is also going to be positive. So now we know that our triangle has a 2 here, a 3 here, and then we can use Pythagorean Theorem in order to find out what our hypotenuse is. So 2 squared plus we don't know squared equals 3 squared. And so b squared is 5, or the square root of 5 is b. So your hypotenuse, your height sine is going to be square root of 5. And so in order to evaluate the sine, we need the opposite over the hypotenuse. And so sine of theta is going to be square root of 5 over 3. And then tangent of theta is going to be opposite over adjacent, so square root of 5 over 2. Alright, next one is the same idea. They're saying that tangent needs to be negative. And so if tangent is negative, looking at our previous example, negative tangent is quadrant 4 and quadrant 2. And so that means that I need a triangle either here or here. And they're telling us that sine has an opposite side, so this side here has to be 1, and then the hypotenuse has to be 4. And so there's no way that this one could work in quadrant 4, because it would need a negative 1, which we don't have. So that means that our image has a height here of 1 and a hypotenuse of 4. And so we need to find that adjacent side in order to be able to say what cosine of theta is and cotangent. Give a little bit more space. So in order to find that missing side, we're going to need 1 squared plus the b that we don't know equal to 4 squared, which means that b squared is going to equal 4 squared is 16, minus 1 is 15, so 15. So the square root of 15 is our side length there. That means if this is our opposite, and this is our hypotenuse, and this is our adjacent, that cosine is going to be square root of 15 over 4, and cotangent is going to be tangent, which is just opposite over adjacent, so it's going to be flipped. So adjacent 15 over opposite 1. Why is that the same? Oh, this is supposed to be a 4. Okay. It just looked like a 1. Perfect. Alright, then we move on to our last problem, which of course is a word problem. Refracted light. Light is refracted, bent as it passes through glass in the figure below. Theta 1, so that's this one, is the angle of incidence. Ooh, okay. And angle 2 is the angle of refraction. Ooh, okay. The index of refraction is a constant, which is mu. Yep, that's our little mu. That satisfies this equation. So if we take sine of the incident angle and make that mu times the sine of the refracted angle, then they will be equal. So if the incidence angle is 83 and the refracted angle is 36, we want to find the index, the mu. So we just plug it in. Sine of 83 instead of theta 1 is going to equal mu times sine of, what's the other, 36. I'm sure they're not telling us to do it without a calculator, because those are not pieces or stopping points on a unit circle. So we just need sine of 83 over sine of 36. Make sure you're in degree mode, because otherwise you're going to get a radian. So sine of 83 divided by sine of 36. And so we get a refraction index of 1.6886. So just understanding where sine could be applied. All right.